heat engine, something that has revolutionized the entire world, which was the basics of Industrial Revolution 3. First, we will not be thinking about the huge engines that normally operate. We are just going for the basic theory of what we call a heat engine. Heat engine, in its very basic concept, is something that absorbs heat from a reservoir, or from, we call it a source, which is having high temperature, and this engine will be absorbing this heat from a source, converting some portion of this heat to work, and the remaining will be rejected to the atmosphere, obeying the Kelvin Planck's second law statement. So basically, a heat engine will be having fundamental thing called source, and the source in case of a heat engine is at a very high temperature, and we normally represent high temperature by the notation T1. T1 is always used for high temperature from this module onwards. So here there is a source which is at T1, a high temperature, and there will be a sink. In case of a heat engine, the sink is normally the atmosphere, where the engine rejects the heat, and the sink, which is normally at a low temperature, and we denote it by T2. So always for high temperature we are going to denote we are going to use T1, and for low temperature we are going to use the notation T2. And in between the source and the sink, a heat engine is installed. Now, how does it work? The heat engine absorbs heat from the source. Okay, it is absorbing the heat. So I'm marking it as Q1. Q1 is the amount of heat that is being absorbed, and converts a portion of this heat to work, to positive work. So I'm denoting it by W, and the remaining will be rejected to the sink, that is the atmosphere. Say I'm representing it by Q2. So this block diagram is now completed. The heat engine, it absorbs heat from the high temperature source, convert a portion of it into work, and the remaining heat is rejected to the sink, which is kept at the temperature T2. That is the basic functioning of a heat engine. Now, the efficiency of a heat engine. I'm going to do the efficiency of the heat engine. Efficiency is always represented by the desired output by the required input. This is a standard efficiency statement. Desired output by the required input. Now if you look at the heat engine, the desired output, what is the desired output? The desired output of the engine is work. And what is the required input? I need to input heat is the input. The input heat, not the rejected heat, the input heat is the required input. Therefore, I can see that I have represented Q1 as the heat which is absorbed, and Q2 is the heat that is rejected. Therefore, efficiency of a heat engine is equal to, what is the desired output? It is the work divided by the desired input is the heat absorbed. There is no heat rejected in the required input condition. Therefore, it is heat absorbed. So it becomes W by Q1. And in case of a reversed heat engine, we are considering the theoretical case where the work done is equal to the Q1 minus Q2. So the efficiency equation can be written as W, that is Q1 minus Q2 by Q1, or it can be written as 1 minus Q2 by Q1. Now this is the fundamental equation that we can use for a heat engine when we know the heat absorbed and the heat rejected. Now this can be written as 1 minus T2 by T1 in case of a reversible cycle or in case of a reversible heat engine, and this will be proved by the thermodynamic temperature scale. But this is also again a very possible equation that can be used for any reversible heat engine.